Nirav sir. Hello, Nirav. Hello. કેમ બોલાતું નથી? Am I audible, Nirav sir?
Hello. A very good morning to all, and welcome to the second day of FDP on blockchain and its application, organized by Department of Computer Engineering, Madhuban and Bhanubai Patel Institute of Technology, and sponsored by Guchcost. Today is an expert we have with us, Mr. Nikhil B. Shah, who will take the sessions on architecture and types of blockchain technology and blockchain platforms. Mr. Nikhil Shah is director at Silen System and advisor at We Nurture Technology. Nikhil sir is seasoned executive, specializes in solutions, project management, corporate consulting. He is director of Silen System and advisor to various early to mid-sized companies to help them growing in APAC and US markets in areas of blockchain, consumer intelligence, cloud surveillance, and software skill development. His focus area include AI, ML, data analytics with Python, R, blockchain, smart contracts, 2G to 5G mobile architectures, and robotics process automation. He has served on the board of Broadband Forum, which is one of the leading industry standard body, where he held several other leadership positions. Currently, he is actively supporting BBF as APEC ambassador. As a passionate technologist and corporate consultant, he supports clients with his combination of futuristic technologies hand on workshop training, that is, digitization, data science, BI, AI, ML, blockchain deployment, disruptive technologies for next decade, Python and R, and leadership skills. He has guided thousands of professionals and students to help making right career decisions. He has been teaching software technologies and networking from his early engineering career. He is actively involved in public speaking and presentations at industrial events. He is recipient of awards such as Leadership Award by Board of Directors, Hong Kong, October 2010, Award by MFA for contribution of evolving MPLS ATM technologies, July 2005, received a Best Presenter Award at Lucent Global SE Forum Bangkok, November 2003, and awarded Best Customer Engagement Award for Lucent Core Switching Division, June 2000. Sir, we are honored to have you with us, and I would request you to please commence the session.
All right. Can you hear me okay?
Yes, sir.
All right. Thank you, Diptiji, for a kind introduction. Probably too long. And thank you, MBIT, for inviting me for sharing some of the observations that we have from blockchain as a technology. So let me allow to share my screen. Right. Can you see the screen?
No, sir.
Can you see my screen?
No, sir. The screen is not visible.
Hello.
Yes, sir. The screen is not visible, sir. Yes, sir. Now it is visible.
Can somebody confirm that? Can you see my screen?
Yeah. Now it is visible, sir.
Yes, sir, it's visible.
I can't hear your feedback.
Yes, sir, it's visible.
It's visible, sir.
Miss Pooja, can you confirm that you can see my screen? Or
Yes,
can
sir,
you hear
it's
me?
visible. Yes, sir. Yes, sir.
Hello.
Yes, sir.
Yes, sir.
Yes. I was just wondering, were you able to see my screen? Because I was not able to
Yes, sir.
hear.
The screen was visible. The screen was visible. We were replying you, but I thought you are not able to.
Yeah, I was not able to hear at all.
Yeah, yeah. We were replying
Okay.
you. The screen was visible, sir.
Okay, let me try again and
Okay.
let me know. Is that now visible?
No, sir.
Okay, and can you hear my voice also? Fine, right?
We can hear
Let me
your
type
voice, but
on the
right now the
chat window.
screen is not visible, sir. You are audible to us, but the screen is not visible.
Okay, perfect. So sorry about that. I think you can see my screen and I'm going to start the session. So I believe you all had sessions yesterday as a blockchain, a bit of architecture and some of
Sir,
the
screen,
background
sir,
information
sorry
about
to
the blockchain.
interrupt. Sir,
Today, in the first session, we are going
Sir,
to
sir,
spend
Nikhil,
some
sir.
time
Nikhil, sir.
on looking at the architecture, probably more from the more of industrial perspective. And I'm also going to talk about number of use cases that blockchain in a practical way, right? Some of the projects that we have worked on. So I hope that would be able to give you some correlation between what you might have covered yesterday and what we're going to look at today.
Nikhil,
And
sir.
hopefully that would set
Sir,
up
it's
a stage for your
visible.
subsequent sessions coming up in the rest of the week. Uh, I had a detailed word with Ms. Pooja and about how this program is outlined. So I'd like to congratulate MBIT for arranging, I think it's a very good lineup of speakers and the topics. And the afternoon second session, we're going to look at more on the different platforms, right? So again, this will give you a bit of industrial view of what are the different platforms and variations of blockchains is being used. All right. So with that, let me just uh, kind of set a stage with some of the observations. If you know that the doctors that was treating you, and if you find out that, oh, I think the screen is not visible. Okay. For some reason, I'm not able to hear your voice, but let me try this now. Is now the screen is visible?
yes, sir, the screen is visible now.
Aditi?
Yes, sir, the screen is visible now.
Okay, thank you. All right. All right, so as I said, these are the two topics that we're going to cover. And one last thing I'm going to ask you, if you guys just can confirm whether you can hear the audio again of the.
Yes, sir. Yes, sir.
Perfect. So let's look at this perspective of what we see, the realities in the market space. This is one of the clip that I'm showing you. So as you can see that there are number of incidences across the world, not only in India, but many other parts of the world, where the fake degrees are becoming one of the nuisance, right? And as you can see from 10th, 12th, doctor degree, you can get it at different rates. Now, based on some of my conversation with one of the university's very senior folks in Gujarat, I think one of the offline estimate is about 12 to 13% degrees are appearing to be a kind of fake degrees. Now, what solutions to this? What could be the applicability of blockchain, right? So if you look at it, one of the solutions that we have partnered with in Block Labs as a solution, where any degree which has been issued by, let's say, MBIT or let's say Gujarat GTU, that degree would have a QR code on it, and that QR code would lead to the private blockchain of that respective university, right? So what would happen that anybody who needs to verify, they can instantaneously go back and within a minutes can verify whether this person has been graduated on so and so time frame from so and so university from so and so department, because that certificate which is published on that blockchain of the college, which has been signed by digital signatures of dean, HODs, the principals, vice chancellor, all the relevant concerned folks. So very unlikely that you can go back and backdated it. The whole reason why this fake degree scam is going on is because it's not about cost of printing the degree, but it's actually going to pay the money and bribe the people from the back end to add those people in the database. So even though in the future any companies was doing the background verification, you will find that person actually into the database, right? But once you have solutions deployed through a blockchain, you cannot go. I mean, of course, you must have learned by now, right, that one of the biggest benefit of blockchain is the traceability as well as the immutability of the records, right? Now, for a various genuine reason, if you need to change something, right, then that is still possible, right? But everything will be recorded, everything will be documented, right? So that was the key reason. Okay. All right. Yeah, I'm not able to see your comments while I'm presenting. So I request Ms. Pooja, but if you need to communicate something, if you want to just type on my WhatsApp message, so that would be easier. Okay, perfect. Now, if we continue on this journey, this whole concept of that fake degree certificate that I talked about, it has a huge applicability, right? Even government, as I understand in LIC, there are thousands of policies are unclaimed. Similarly, there are huge frauds happens in the share certificates, right? So there is a whole concept of just like shares are now dematized. Similarly, life insurance policies can be dematized, and just like degrees, they can be also be kept on a blockchain, right? So we'll look at some of the other applicability as we go along. But let me just get the quick observation. So I'm going to share you another video. I just want to all of you to have a just look at it and then tell me what you can type on the chat window. What I want to observe is any interesting angle from future frauds, or how can blockchain can be used for minimizing certain kind of frauds. So just have a look at the video and we'll see how it can be applicability. This is one of the medical scene. So there are a lot of privacy related concerns where blockchain can be helpful as well. So let me play that. Google has some issue with sharing the inside video, so I don't know whether you can share, you can hear the audio part of or not. But all right, so uh, can somebody make a comment that when accident happens on the road, uh, particularly many times some of the influencing people, because of reckless driving, uh, they get into accident. Many times loss of life happens, and those cases do get registered, but most of the time the highly influencing people get away with it, right? Now, can can you comment um, how that can be addressed with the blockchain? Right. So I'm not going to name the people, but let's say there is accident situation occurs, and all the parties involved in the accident, they will be registered right at the scene of accident with their respective private identities. And once that is entered inside the, let's say, Ahmedabad Municipal Corporation or whatever the Department of Motor Vehicles records, once it is there in the blockchain aspects of it, it's virtually impossible later on that person would say that, oh, I was not at the crime scene, or whether I was not there at the scene of accident. I was in other city or other country on that day. But now that is not possible because other than your private identity, it wouldn't have been recorded to begin with, right? So many situations like this where you will find blockchain applicability will be quite relevant. Now, before we get into some architecture aspects of it, I want to just give you a perspective of uh, uh, how the economies are evolving, right? And particularly sharing economy and the what's the role of blockchain. Now, I'm sure you must have heard about Airbnb, which was recently, went public, and within a days, it has got the market capitalization almost at 72 or 70 to almost 100 billion, because every day stock price goes up and down. Uh, but they took about 4 years to reach to capacity of 650,000 rooms in across the world in 192 countries. Right? You know about a bread and breakfast model where you have surplus capacity at your home and you can rent it out, just like many people rent their cars to Ola or Uber, right? So that is called sharing economy. Just on a comparison, one of the largest hotel chain in the world is Hilton. It took them 93 years to build a similar capacity, and they did not even reach to half of the countries, right? And that market cap, even after owning so much of properties, is almost just 28 billion compared to almost 300% more in Airbnb. So that's the power of sharing economy. So what I'm trying to just say in the next few minutes that what I believe is blockchain is going to be is what internet that 20 years before. So it is not just one of the application of internet, like email is one of the application of internet, uh, or Paytm is could be one of the applications of internet, which and obviously there is other payment integrations into it, but largely because availability of online. But blockchain is just whole another paradigm shift, which includes internet, which includes computer science, which includes statistics, mathematics, security. Um, so there's so many components are involved, which makes the whole solutions, which is not just IT, but going to be applicability to so many industries, right? And that's what we're gonna look at some of the industrial examples today. So just to kind of, in 30 seconds, uh, just look at the big trends and how blockchain fits into the overall equations as it's evolved into overall internet architectures. So we all know that data is new oil, right? Most of the wars happened in last 50 years, or I would say last 100 years, as largely contributed to oil is a big contributor. But the future oil of 21st century is going to be data. Now, if data is oil, then we use machine learning to extract the information out of the oil, just like refinery would extract the petrol or oil out of the raw oil. Similarly, machine learning is going to find actionable decisions out of the data. So that's why we call it machine learning as a refinery. Similarly, we will call it 5G as a new transport system, right? Because 5G, as we all know, is going to bring quite a bit of revolution in terms of latency. I spent pretty large part of my career when I was in US designing large scale um, telecom networks across the world. And in 4G, almost latency is, I'm sure all of you are from technical background. So latency is almost at the rate of 50 millisecond versus 5G has a potential to bring the latency to almost 4 to 5 millisecond, almost 90% less compared to 4G. And that would bring a lot of new applications like remote surgery, driverless car, industrial automation, which wouldn't have been possible. So see, the speed doesn't matter. The speed obviously is important. 5G is going to give you more speed, but more importantly, the latency part, which is going to be really critical in a real time mission critical applications. So those are the new wave of applications are going to happen, like drones and stuff like that. So we call it 5G as a new way of transporting the information, and the most importantly, the blockchain. In the same context, we would call blockchain as new settlement system, right? Why we call it new settlement system? Because uh, uh, so uh, uh, one of the key reason for most of the disputes happens in the industry, right, or in the real world, is because of non-agreement between the on a particular matters, right? So uh, one of the characteristic blockchain offers is immutability, right, or transparency and the, traceability, right? So we'll look at certain examples where we'll see all these three examples are going to be relevant. At the same time, just like many other industries, there is always a hype cycle goes in the industry, right? That everybody jumps into it, and many startups are claiming that they have blockchain enabled solutions. The challenge is not in every problem blockchain would be relevant, right? So in the second half, we will look at certain aspects of it, which is kind of very thumb rule, like is not fully scientifically proven, but there are some thumb rules which you can help you to identify whether is it really relevant for blockchain to be used in these examples or not. So all these technologies, I think we are in a very interesting time in next decade, particularly next 5 years, is going to be really critical, where all the 4 points that I talked about earlier, right? Data, machine learning, 5G, and the blockchain. I think it's going to bring some really cool stuff that we'll see in coming years. Right. So as I said, right, this is every some of the statistics I want to highlight that even though, as I'm sure you must have heard or you must have read about before, if you would have been looking at blockchain, the Satoshi Nakamoto name is not a new name to you, right? So this whole thing was started in 2008, but just like every industries goes through a different cycle, is bring to a maturity level, and one of the way to measure that is how much is the media coverage happens on this. So these are the different terms you look at from since 2014 to last many years, but this just 2017-18 when you start seeing the massive search and media coverage on these technologies, and partly it was driven to a Bitcoin prices as everybody's in the world that's got attention to this. So just to summarize a few things, and again, I'm not going to go to all the details, which as I assume that some of the topics would have been covered, but I will do a quick architecture, quick demo, so that just in case if you would not have come across or not attended earlier sessions, this will give you perspective, which we wanted to highlight that architecture, like what is the fundamental building blocks. We'll look at in a very quick quick demo perspective. So if you have to just understand blockchain from a one perspective, that is essentially a database, right? Just like you have SQL database, you have many other relational database. Think about blockchain as one of the database where particularly untrusted parties can come to an agreement on the state of database without using the middleman, right? So one thing we should understand that blockchain potential is to eradicate or eliminate the middleman in whatever shape or form possible. Not in every application middleman can be eliminated, but in general, the idea is you remove the centralized notion of a particular topic of when many transactions happens, like I want to transfer money from point A to point B, right? So let's say I'm sitting in Ahmedabad and I want to transfer some fund to Japan to my business partner who is going to send some merchandise and I need to pay him a payment. Now, typically, if I didn't know that person, we just meeting for the first time, it will probably take hardly a minute for me to send an email to that person, right? Not even a minute, right? I just get his email address over the phone and then I'll just send him an email. But what if I have to send money to that person, right? It's definitely not going to be a minute, right? Particularly, there is no prior banking relationship established. In that case, it will take a couple of days, maybe 4 or 5 days, where both sides, both banks has to agree, and then you can do wire transfer or any kind of money transfer. Of course, within India, you can use some kind of mobile wallet application, but still there is essential to have a KYC done prior. But here we're talking about international boundaries. But in this case, there is a middleman involved, right? There is a central bank involved. There is a both countries bank involved, and by the time you get the money, it will be a couple of days, as well as there is all kind of fees involved. Even today, any money to be transferred from US to India is typically incurred from $40 to $50, right, for that transaction, which is quite a bit of money, right? If you want to do some regular transactions. So that was kind of an essential concept where people wanted to use the blockchain, and the one of the paper that was I would highly recommend, since you guys all are quite research oriented technologists. There is a peer-to-peer communication, peer-to-peer cash transfer white paper, which is under the pseudonym of Satoshi Nakamoto, and that white paper has all the very essential concepts of blockchain listed in it. So if you look at number of applications in banking, HR, insurance, records like land registries, birth certificates, security, I mean, you name it, this is going to be a good amount of application that you will see. some of the reference point that blockchain and AI is quite beneficial to agriculture and many other sectors, as our Prime Minister has also mentioned publicly in some of the different forums. Now, one of the angle, just in case some of you may not be aware about it, that Dubai in UAE is quite in forefront of using blockchain. I was there in before the lockdown. There is a giant event happens called GITEX in Dubai, which is quite a representative of many IT solutions across the whole Asia Pacific and Middle East, where blockchain was quite aggressively being highlighted by the government themselves. In fact, if you look at it, what the Dubai government is claiming that they wanted to go completely paperless, which is a very bold claim by December 2021. And they are looking at many emerging technologies, including blockchain, to reach that goal. In fact, what I recall from that conferences at various government agencies was highlighted. Almost, I would say, 60% of government agencies have already shifted or in the process of shifting to a blockchain-based ecosystem. So for example, if you want to buy or sell any apartments or flats in Dubai, or anywhere in the world, typically what happens that you would in India we put the advertisement into newspaper to find out there are any loans pending on this property or any kind of claims in the property or any disputes on the property and all of that, right? Now, if you are applying that thing to multiple banks, each bank has to do that verification, right? But government already have certain amount of data, right, with all central data from all the banks. So that can be put on a blockchain. So if somebody is applying for a apartment loan papers in XYZ bank, now the XYZ bank would have access to a central blockchain repository, which is managed in a cooperation with government. So that bank would instantaneously get the verification, just like the example that we saw earlier about background verification, right? Typically, for companies, if you want to do a background verification, it typically takes 4 to 5 weeks, right? Because they send the paperwork, universities look at that data, they contact the respective college and do the background verification and reply back to the whoever is a company or recruiter wants to do background verification. As we talked about it, right, that can be reduced to in a matter of minutes. Similarly, here the whole loan process, right, where the bank before they issue the loan, they want to be assured that there is no other pending loan from any other bank, right? So that if it's on the blockchain, then it's completely trustworthy and it can be traced back, right? When the previous loan was taken, when it was paid back, and all of that. So this is one of the classic example. I would say in my observation that Dubai is probably way ahead than any other parts, any other cities in the world in terms of adopting the blockchain. So I encourage, if you are interested, just look at the various, you'll find enough information on the net about applicability of blockchain. Similarly, Keralian government also have some very interesting initiatives. In fact, I've seen some of the press about there is expecting or they're planning to, create almost 25,000 blockchain professionals, and they have taken various initiatives for an education perspective and whatnot. Now, let's going back to the blockchain architecture, right? So I'm going to just throw certain terms that give you some very crude perspective without going into very complex definition. I think we should get a good clarity in our head, the point of reference at how we should look at the blockchain as a technology. So essentially, in a one line, if I have to summarize, it is nothing but registry of your assets and the transactions, right? So your assets could be your tokens like Bitcoins and your land records or your birth certificates or your SAT certificates, right? All of that. Those are the assets, and any transaction happens on that assets that will be registered in a blockchain. I'm going to also share with you one of the use case which we are currently working on, just to give you perspective, which is about machine learning code base, which is essentially number of companies are looking for machine learning experts, but that's a very expensive skill set, right? If you want to hire 5-10 years experienced machine learning expert, but what if you want to have a routine need of regular machine learning repositories, which is available on a GitHub? So we are working on a solution which is blockchain verifiable machine learning repositories, which is matured in terms of validity and accuracy. So I'm going to talk about that. So that will give you perspective of how different blockchain applications can evolve. Right? But again, why I brought it up, that the code base or your machine learning code, which is written by various machine learning developers, that is their assets, and we're going to put that on a blockchain for various transactions, so that you have a complete verification of that code base, that in terms of the maturity of the code or the popularity of the code or who else has bought that code base in the beforehand, right? So we'll talk about that. So essentially what blockchain does is going to make the things so we have complete, safe, secure, auditable, and importantly resistance to outage, right? So whatever you guys have covered earlier, because of blockchain nature, that even though some part of the network is dead, you still have information available, just like in a centralized repositories or centralized way of information sharing. If the main side is down, there is an outage, right? The blockchain by design, it will eliminate that problem. And one of the things always, as a thumb rule, keep in mind that it has potential to eliminate the middleman in many of those applications, right? So we talked about money example, right? That you want to transfer money from point A to point B. The Bitcoin is kind of application which makes it really possible, right? If you have any exposure to MetaMask, if the term is familiar to you, that enables you to literally create your crypto account in matter of minutes, and then you can do some transactions. So I'll show you those who are not familiar. We'll look at that as one of the case study in the second half, that how you can use MetaMask to play around with the Bitcoin or Ethereum on your test network, right? Obviously, real Bitcoin would be quite, expensive item to trade. Like almost last I know is about $19,000. The price was going on. We'll look at Bitcoin a little bit, but just to give you perspective, there is the example that I talked about earlier about intercontinent transfer, right? So Ripple is one of the coin which was introduced. There are hundreds of coin, hundreds of tokens, but I want to just highlight one or two just to give you perspective. So Ripple is one of the San Francisco based company with 300 employees, and their focus has been the cross-border payment solutions, right? Just like I talked about earlier, when the different banks, when transact massive amount of currency or massive amount of the amount across the border, the Ripple is one of the platform which enables the transactions very efficiently, right? So this is designed for financial institutes to transfer money from one currency to another currency in matter of seconds, which otherwise would have taken a long time. And this, I'm sure some of you must be familiar with, the SWIFT is a system. So this is going to be a direct competition to SWIFT, but it can, eliminate from any to other currencies, right? So there's a lot of flexibility and scalability is offered. Now, before we get into blockchain architecture discussion, if I want to ask you, what is the third largest country by the population? What would you say? If you can just type on a chat window. Yeah. What is the third largest country by population? I think people are doing Google, I guess. Obviously, India and China are the China or India are the top two. I would just say the third largest country. Earlier, it was Facebook. In fact, if you look at the current numbers in just last few years, people used to joke like everybody knows that India and China are the largest populous country, but even the Facebook, the current subscribers, or I would say Facebook citizens, they're almost 2.7 billion in my recent check. So in that way, the first one is Facebook, second is China, and India is the third largest country by the population. Why we call it nation? Because Facebook has a loyal customer base which go and like their country every day, pretty much, right? So this is another currency I want to just highlight. The Libra is the permissioned blockchain. This is another cryptocurrency which is backed by actual fiat currency. When we say fiat currency, means actual dollars and euro. And there are a number of organizations are participating into it, led by Facebook. There are some disputes going on in a recent time where MasterCard, Visa, and some of the large companies are not sure about how much they want to go in. But Facebook is fully committed to bring this Libra. In fact, you might see some early announcement as early as January 2021. So this is going to be a huge transformation. I'm sure you must have seen that WhatsApp is now getting some permissions to have their own transactions like mobile wallet. Similarly, you can also use WhatsApp to do some kind of money transaction, which is owned by Facebook anyway. So the idea of these currencies or these concepts that think about in advertisement model. We all know that Google makes 90% plus revenue from the advertisement, right? Because we only know Google as one of the biggest search engine, but they are one of the biggest ad advertisement company as well. Similarly, Facebook, a large chunk of revenues are coming from such assets in advertisement and so on and so forth. So, think about the scenario where, somebody has put their new announcements of the product, or Samsung or XYZ company is launching their new phone, and it's across the world, seen by millions of people. And if you are watching that whole advertisement, if you watch that 10 advertisement, or if you give some comments and feedback about that particular product, you're going to be given 0.0001 Libra, for example, or 0.1 Libra. And then over a period of time, you would have 20, 30, 40 Libra, which is also going to be viable token that can be used for buying something or doing some internet economical transactions, or you can use your Libra to access some of the premier content and so on and so forth, right? So you can imagine with 2.7 billion people on Facebook transacting pretty much on a regular basis, and the Libra can be a very powerful vehicle, right? So this is a whole new world, how things are going to be worked. So we all know that, as I mentioned earlier, I highly encourage you to just print and read this paper. I think you'll give very interesting perspective. Quite remarkable thought process ahead of the time has been established since 2008. So for all practical purpose, Bitcoin is, you can think about as blockchain 1.0, right? Ethereum, which we're going to look at in the second half a little bit, as well as I know I looked at your agenda put together by all your MBIT professors. I think there is Ethereum and smart contracts is also coming up in some of your future sessions. So we're not going to go into a lot of detail on that, but just for your simple understanding, you can think about blockchain as, let me just type it here so that so you can put Bitcoin as blockchain 1.0. You can put Ethereum as blockchain 2.0, and then Hyperledger can think about as blockchain 3.0. This is just, there is no industrial standard terms like this, but I'm just referring to using this terminology so that easier for us to refer to. The first one, the blockchain enabled Bitcoin, right? That was the first application how the blockchain was launched in form of Bitcoin. So in that one, Bitcoin is permissionless, right? There are another way to look at blockchain, permissionless and permissioned blockchain, right? So in a way, this is blockchain or Ethereum, right? That sorry, Bitcoin and Ethereum, there's a blockchain 1.0, 2.0. These are all permissionless blockchain, right? Because anybody can join in that ecosystem. As far as you have a open and secure internet access, you would be able to participate into this blockchain ecosystem. Versus private blockchain or enterprise blockchain, where only people who are invited. So you can think about it as a membership is on invitation, right? So you can think of those as a permissioned blockchain, right? That means they are more of a on-demand or on invitation based. So it is in a small circle. It is controlled by a specific company, a specific enterprise, which give the permission. So that's why we call it as a permissioned blockchain versus the Bitcoin and Ethereum. You can think about that as a permissionless. By the way, feel free to unmute yourself and ask me any questions. We'll try to take it in the middle, or we'll I'll address them towards the end. Okay. Now, I'm sure all of you aware quite a bit with cryptography and hash functions, which I assumed would have been covered yesterday. But just to reiterate some of the point, like there is all kind of cryptographic hashing functions and algorithms are available, like MD1, MD5, secure hash algorithm, SHA-1. Right now in blockchain, it's using like SHA-256, which is one of the most considered as one of the most complex cryptographic hash functions, right? So let's look at quickly the architecture perspective. So I'm going to, can somebody just confirm that you can see my screen as a screen of change?
Yes, sir.
Can you see this? Yeah, perfect. Okay, so I'm going to go a bit quickly. Just the whole concept. Let's look at the whole architecture from end-to-end perspective. First of all, we know hash function, right? What hash does? Hashing is nothing. It's not the translation. It's just the encryption of your data, right? So if I type, now as I type, your hash function changes, but the length of the hash function is not changing. It's always remain constant. But even though putting one full stop is changing the complete hash function, right? So that is one of the secured hash function, and which will connect with the cryptography in a minute. Now let's look at, expand this demonstration a bit further. Let's look at the block, which is a block of a blockchain. Uh, Now, whatever we saw in the hash were essentially your data, right? Your data is, the interesting observation to make here is your data needs to be secure. So whatever is there inside your data, which is, let's say, MBIT received uh, recognition from, let's say, just, MIT for certain innovation. Now, let's say there is some secure information here that needs to be highlighted, that needs to be represented by a unique hash, right? If I make a single change, hash changes. But if I go back to my original data, MBIT received recognition from MIT, right? That gives me unique hash function. Right? So any data, which could be one whole encyclopedia, which could be your resume, or which could be 10 million records. All 10 million records can be uniquely identified by hash functions. Hash function for a given data, hash function is going to be unique all the time, right? So that's point number one. Now think about this data. Just focus on the data. I'm going to divide the data into two parts. Let's call it as a block. So data is now further, let's put it divided into three parts. One is a block number, second is nonce, and third is the data, right? Now this is the one basic building block of the blockchain, right? So obviously data needs to be secure, right? So this portion has to be secure. The block address, which is the address of the block in the blockchain, that obviously has to be the same, right? That you cannot alter the address. So that's why this is been introduced, nonce as a concept, which enables you to make your block acceptable inside the blockchain, right? So hopefully this will give you one probably refresher, as well as some perspective for those who has not perhaps joined yesterday. But as look at it, as soon as I type something in the data portion, the block was originally green block, just a color code, just so that visual representation would help us to understand it better. As soon as I put some data into it, that $100,000 has been transferred from bank A to, let's say MBIT or something, right? Now this block is become turned into red or pink because your hash has changed. So always remember, hash is a function of all these three things, like block address, nonce, and the data. Now, as per original architecture of blockchain, the hash function is to have a actually there are 12 leading zeros, but for this demonstration purpose, we are going to say that you need a 4 leading zeros. So essentially, think about that is this is going to be trial and error mathematical function, which you change this value of nonce, because block address and data cannot change, right? Because you want to obviously preserve the data. You want to make sure that data is not altered, not even bit, right? So data cannot be changed, block address cannot be changed. So what do I do? What kind of mathematical function that I run so that I get leading zeros in the hash by changing the value of nonce? That is the process of mining, right? So if I mine this block, now see, it got 4 leading zeros, and now this nonce value has changed, right? Now this block is now permissible, addressable, or admittable inside the blockchain. Now you might wonder that what is a mining, right? So mining is just essentially a process. I just want to show you something like, if you go to, let me try on Amazon. Yeah. So you can go to Amazon and buy all kind of mining machines, because you can be a miner also. Miner means the guy who's going to do that process faster than anybody else, because this problem is going to be given to everybody who want to participate into whole blockchain economy, right? So as you can see, these are the different mining machines. That is, people used to make a lot of money in earlier time when this was new concept, right? So these are the, if you can see my screen, these are the different machines, which is in a couple of $1,000, because it views FPGA and ASICs to, and heavy duty of GPUs, like $10,000. Used to be quite expensive. Nowadays it's been less. So these machines essentially are very heavy on the computation, and they calculate this functions so that you get nonce in a such a way that you get leading zeros. So that is the nutshell of the blockchain, right? Or a block. Now let's connect things together with the blockchain, right? It's the same concept. This is a block number 1 that we were just looking at it. Blockchain 2, blockchain block 3, block 4, so on and so forth. Now, interestingly, I'm sure you know that this first block is called Genesis block, or the first block, and every block. So this is a second block. What block contains? The block contains the transactions. Typically, you would find a couple of hundreds transactions in a block. Typically the size of the block in the real world are in the range of 1 MB. And now recently, certain block has been increased the size to 2 MB, but that's the typical size of the block. And I'm sure you would have heard yesterday that current Bitcoin ecosystem, it takes about 10 minutes to process a block. So all the transactions in last whatever the minutes, once they're admissible transactions, once they become the part of the block will go through a mining process. Whoever mined the block first, that block is now added in the part of blockchain, and now it's circulated to a distributed decentralized system, so that everybody who is part of blockchain ecosystem would have the same copy of the blockchain. Right? Now let's look at this in a little bit more detail. So here, obviously the data contains the secure data. So let's say A transferred 100 rupees to B, right? Now the data has changed. So obviously this block is not admissible, because as you notice that the leading zeros gone. So if I remove this, you'll find all leading zeros. All the blocks which are admissible in a blockchain would contain the hash function, which is leading zeros. Now, another thing, just to give you perspective, that the previous, each block, just think about this as a simple linked list or one-dimensional linked list or one-way linked list. Here, from block 2, I can go back to block 1. From block 3, I can go to block 2. How? Because you see this previous function, which is highlighted here, 0005 to 48F, right? Where is my pointer is, which is nothing but the hash function of the previous block, right? So this is how I'm going to point to the previous block. Similarly, the hash function of point block 2, it is the previous address of block 3. So it's a reverse linked list. Think about reverse singly linked list in a very simple term. Now, when I put some transactions here, obviously the data has changed. Now, for this block to be admissible, I have to go through a mining process, which I just showed you that people are rewarded, right? Because this is, the computation is not free, right? And that is one of the drawback of Bitcoin, that earlier it was okay, but nowadays, as not many transactions are happening on a whole Bitcoin economy, so it is a computational heavy, right? So people who are going through a mining process, and whoever is going to find the first leading zeros, right, he's going to be a winner. And that's why, according to original concept, there is a 50 Bitcoin was a reward for successfully mining a one block, right? So you can imagine that's a quite healthy money, right? Quite a handsome of money. So Bitcoin price in rupees, as you can see, that's 14 lakhs. One Bitcoin is a 14 lakhs rupees, as you can see on your screen. In US dollar, it's almost 19,000 USD, right? So that amount of money for one, and now we're talking about 50, right? So 50 into one BTC. I mean, you can imagine, like 20 times, so 20,000 times 50, almost that amount of money it's 1 million, I believe. So that was a reward, and according to the original concept, every 4 years the blockchain reward for mining a block has reduced to half. So later it was from 2008 to 2012, it was 50, then it's about 25, and then 12, and then 6.25. So now it's going to be 3.25, right? So if you mine a block, your reward is almost like 3 to 6 bitcoins, which is almost $60,000-$70,000, right? So that's very handsome of money. That's why a lot of people still involved in heavy duty of mining. But essentially, those who are who has a huge computation power, they are usually the winners. So there are a number of Bitcoin miners are available that let me quickly show you. Right. So here, you will see all the transactions happening in the world on this. There are a number of exchanges across the world which let you look at the different one second. Yeah, so I'm sure here you can see that these are all the transactions on your screen that which is live right now. It is 11:32 a.m. right at the local time, and as you can see that this many transactions are happening. This many BTC is a Bitcoin, and its equivalent value in dollar, right? So every second or every few seconds you see that this much of amount is being transacted, right? $209 or 84,000 US dollar, right? It's almost 60-70 lakhs rupees. So this is the transactions being taken place right now as we speak with live data. So I'm looking at just one of the transactions, and here you don't know where money is, like but this is the address from this person to this person. Like out of 133 Bitcoin has been given to these two parties. One got 1.32, another one is 0.09. Now this process, as I said, in the whole mining process, there are fees involved, right? So this is the fees, which is the mining fees for so to execute this transaction. Now again, there's a difference, right? There is a mining fee for mining the whole block, and there is a transaction processing fee, which is a 0.0010 BTC, right? So all the data is available. I will encourage you to explore this in detail. You will learn a lot about it. So essentially, we are looking at the data here, which is nothing but the transaction that I just showed you, right? The number of transactions are taken place, and once those transactions are filled in a block, that block is going to be mined along with all the transaction and then be processed. So if anything changed in middle, right? If anything is changed, it will invalidate the block, and that's why you have to remine. When you mine the block, you get the leading zeros in the hash function, and then that block is admissible. So right now it's in this demonstration, the mining process is going on, and now you see there's got leading zeros, and that's why the nonce has changed. So point is, even though if you change any one block, you would need to change the rest of the block, and that is the core reason call it blockchain is very resistant to change. So if you have a block and somebody's maliciously wants to change some data point, then you need to mine a block, and mining is expensive process, as we just saw, right? And mining, let's say there are 10,000 blocks, which is all needs to be mined for to be validated. Because if you just change your own blockchain, doesn't matter, because rest of the world, rest of the distributed ecosystem all has to agree, all has to accept your changes. Then only the blockchain is going to be fine-tuned, and it will be acceptable by rest of the world. And that is how the whole core reason how the blockchain validation algorithm works. So here, so we got the idea about blockchain. Now let's look at the understanding of distribution, like we call it distributed blockchain, right? So essentially I have multiple copies, just like I have a pretty, if I have 500 GB laptop, right? I can get the dump of whole blockchain, particularly the Bitcoin blockchain in my machine. And you can also be one of the miners, and if you're lucky enough, you will be able to get the reward. But as I said, the people who have a huge mining farm, they have a very, very large data centers, and the only job they do is just mining, like 24/7, because the amount of investment in millions of dollars they have done, and very likely that they will be able to finish the mining first than anybody else. But just for your knowledge perspective, you could be a miner, you could participate, just follow the steps and you can be one. What I'm trying to say here is the distributed nature of blockchain, right? So this is let's say a blockchain in one of the machine. This is another distributed blockchain. This is another one. So similarly, there are a number of copies across the world. Again, all this information you can find out on the net. If you are interested in some of the statistics, they're quite fascinating, that how many parallel blockchains are there, how many total number of blocks are part of the Bitcoin blockchain. You can find those information, latest information. Now the thing is, if I change something here, now makes this particular blockchain invalidated, right? But the rest of them are still having leading zeros, right? So my processing, if I mine this block, that needs to be acceptable by all the other peers. Then only the transactions become valid, and right, that is the power of distributed nature of blockchain. So number of parallel copies, and each one has to agree on that, and that is where the concept of proof of work, and right, that is the mechanism used by various mechanism, that whoever is giving you that, look, I finished the work and I mine the block, and all others accept that as a proof of work, and then the blockchain is accepted. This block is accepted in the blockchain, right? So there are a number of algorithms. They call it consensus algorithm, right? How different parties comes to a common consensus about accepting this block as a part of the blockchain. So Hyperledger, Ethereum, Bitcoin, all have own different mechanisms of proof of work, proof of stake. There are, if time permits, I'll touch on that in the second session. So this is how the architecture looks like. Now let's look at even more realistic. Since we look at the distributed blockchain like PRA, PRB, PRC, now let me give more realistic example where there are transactions are included, just like Bitcoin transaction that I showed you earlier, right, from one address to another address. So here, just for easy to understand, we are actually putting some names, but in reality, it won't be a name. It will be just address of your wallet, for example, or Bitcoin wallets that will be going. So you will never find a true identity of who is transferring to who, but you will just have a address of that person. So here, all these transactions have been taken place. So here, what happens that the $25 is gone from, let's say, Nikhil to Amit, for example.
Excuse me, sir.
And this block is now mined. Once the block is mined, it's acceptable. Now this is now permanently recorded in the blockchain, right? So now in the ledger, information is known that Amit has a $25. So in a subsequent block, when Amit is trying to give $50 to somebody, then that is not possible because this is called double spending, right? Amit only have $25. He cannot give more than $25, but he can give certainly $12 to somebody else, right? So this is how the process would work, and all these transactions getting validated, and then once the block is mined, it is going to be added into blockchain, right? So it's going to take some time. So let it run. Meanwhile, I'll just quickly, yeah, let's just finish, right? So you see, it's all got 4 leading zeros. No, sorry, I moved to Coinbase. The Coinbase is one of the big exchange. Let me show you. Right? Hello. Oh, okay. I'll look at it. Yes. So there was a question on our chat box. Let me quickly look at it. I need to figure out to have both questions at the same time. Okay. So question is it possible to mine using CPU, GPU based machine instead of using such costly ASIC, regardless of mining reward? Yeah, but it would take conceptually, there are algorithms which is getting downloaded on your machines, and those algorithms would run on the machine. So depends upon the computation power, they will be able to run. So I don't know how much time it will take, but yeah, theoretically it is possible, right? Because there was no GPUs available back then in 2008, right? Or probably were very early stage. So short answer is yes, you could. So here we're looking at the Coinbase transactions where there is a money, for example, $100 was started by Andreas, and now his Anders is giving $10 to Sophia, to Lucas, Emily, so and so forth, right? So that is in a block 2. Now in the subsequent block, let's say Emily is giving to Jackson $10, but now that is part of the distributed ledger. I can go back and verify, because actually this Emily indeed had a $15, right? And that's why she can give that $10, right? So this is in a way eliminate the double spending as well as the fake currency problem, right? I'll tell you the true story. Couple of years back, I was in China, and in Beijing for one of the conference. I went out in a taxi, and while coming back, obviously language was still a barrier there at the time, and I given 100 RMB note or currency note to our driver, and he said something which obviously I didn't understand, but he seems angry, and he gave me the he gave me the currency back to me, and say it's a fake and something. But this money which I literally had picked up from the airport, from the ATM machine, so obviously it cannot be fake. But I didn't know what to do, so I had a couple of other notes. I given another one. He again was mad at me, and he gave me that note back because he was sitting in the front row, front seat, and I was sitting in the back side. And this happened 3 or 4 times, and then I told him to let's go back to closer to the hotel, and I asked hotel concierge, and I said to him that this guy is saying something, and finally I given him another currency, another note, and he accepted it. What I later realized that these 4 currency that 4 notes that he has exchanged, actually I was keep giving him the real one, but he was giving me back the fake one. He was just twisting it. So in the whole attempt, in just finishing the paying the bill for the taxi, I end up getting 4 fake currencies, and I end up giving 400 RMBs to him. That I realized on the second day, and I know how I got fooled. But see, this is a one case study that I just myself has experienced. So this is a fake currency. Now here, that whole just like fake degree, right? Similarly, in a Bitcoin, right? This everything is on a digital format, the way we are talking about, right? So that whole problem can be eliminated altogether. Okay, now So hopefully this will now give you the perspective, right? That if anybody is trying to change even single thing like 10.01, that block would become invalidated. You have to again mine it to be part of the whole ecosystem, right? So this hopefully this would give you perspective. Now let's look at the cryptography for a second, right? I'm sure many of you are computer science students and you know the public private key combination. But those who are probably new to this, I'll just quickly take 2 minutes to explain. Uh, think about your email address, right? I'm sending email to somebody. My email address is a public key, for example, right? And my password of my Gmail account is a private key. Obviously, I'm going to tell everyone about my email address so that they can communicate with me, but I'm not going to share my password obviously to anyone. Similarly, private key is the password. Or uh, think about this, that uh, the combination of private key and a public key is unique. So for example, I'm generating the new private key. Look, I'm keep generating new private key. Similarly, correspondingly new public key would be generated. So there is always private key and a public key goes in a pair, right? Think about that as a, but think about that my thumbprint or my fingerprint, it's my private key. But if my if I put my thumb key at the airport or any biometric machine, they can identify me. So me as my public key, me myself, right? So my just little bit of my thumbprint gives me the whole identity, right? So now look at the signatures, the concept of signature. Now there is a message here which I obviously need to secure. So Nikhil has given $1,000 to, let's say, Miss Pooja, for example, right? Now this message is, I'm going to sign it with my private key because I'm the only one who knows my private key. Nobody else knows, right? As we just talked about. So I'm going to sign that transaction with my private key, and that generated the unique message signature, right? Now look at the unique message signature, start with 304. And just for fun, I'm going to copy this. This is my private key. That's on your screen, right? Start end with 645, right? This is my private key, and this is my message signature, okay, which is there in the below. Now let's say I send this transaction to somebody, and now let's say Miss Pooja or XYZ third party in the middle want to verify that this transaction is valid or not. So now they're going to verify. Now in the process of verification, now notice that obviously they do not have my private key, but I already announced my public key to the world. So they already know about my corresponding public key. So message is the same and they know about my public key, and I'm going to ask for verification. So what verification process does, that it will generate the new signature and it will validate with the signature that I received, right? So let's put this new signature, and the one that I signed, my original message signature, right? As you can see that both of them are exactly same, right? So this is how when I signed something, I use my private key. When somebody verified my transaction before accepting it, they used my public key, right, which is already announced to them. So this is like how basic signature verification works, which is kind of obvious. Now same thing concept is, extend this concept to a transaction, right? That just like we looked at it here, we don't have actual name, this is just the addresses. Think about this, a private public key. Public is known. So this public key, this person has sent $20 to another person, right? Now this transaction is signed by the private key of the sender, right? So this is the private key of the sender. Let's verify this. See, you can see, right, that the exactly same key that I talked about earlier. I'm going to sign that, and then message is generated, and again verification happens with using my verification happens using my public key, right? So this is how it happens. And if you extend the same concept in a blockchain, each transactions which is part of the blockchain are validated using this mechanism, right? If I make even slightest change to 10 point or instead of 10, I'm going 100. That made this transaction invalidated, right? Remember, I told you that each transaction is to be validated, and then after that, the whole block needs to be mined. So this is how it's going to work, right? So hopefully this give you quite a bit of perspective of whole hashing mechanism and the blockchain works. Now, allow me to share with you some of the applications of how we can look at. So if you can see my screen, I'm going to show you one of the application, which is Spring Roll. Now, what is Spring Roll? Spring Roll, think about that as LinkedIn on a blockchain. I mean, all practical purpose. So if I go to LinkedIn and I call myself as I'm the Google India CTO, right? I mean, nobody stops me. I can, or any MBIT, one of your professor claim as I am the GTO vice chancellor, right? I have my prior experience. There is no way that is going to be questioned, right? Because it's your, you advertise yourself, right? That's a LinkedIn. Obviously, LinkedIn is one of the very popular platform, but this mechanism is not there. You can fake your identity, you can fake your previous experience, right? Now let's look at the Spring Roll for a minute. I'm going to log in using my Google credentials. I don't know why it's taking time, but Google had a decent outage yesterday. Okay, so now this is a blockchain enabled system. So now look at it. I have my experiences here. So for example, if I say myself as a director, this I'm in a predically, I was with, let's say Juniper Networks. Now, here is my experience has been placed, right? That I was a director of advanced technology, blah, 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 at Juniper Network from so and so period. Now, understand the beauty of this concept. Here, I'm going to request peer verification pending. So I'm going to say request for a verification. So this automatically goes to Juniper Networks. So Juniper Network HR department are going to validate it. And that whole validation process is going to be on a blockchain, right? So next time, let's say if I'm applying for some senior role with some company, now that company wants to verify, obviously all the senior positions, they do very thorough background verification all the way going from your schools to all your previous employers and so on and so forth. So if that typical background verification process going through, let's say 3-4 universities or 5-6 or employers, it will take a couple of weeks easily, right? Now here, if you go to this, if Juniper Networks HR department has already pre-verified me, that means here it will see the tick mark that company verification is completed. That means Juniper Network, and it will be traced back to Juniper HR in their blockchain. So Spring Roll essentially is offering the identity verification from different employers in a single template. And so think about this as the same as my LinkedIn profile, but each of the employer and each of my college degree has been verified by the respective university or respective employer, right? So that's how it will be visible. Now, let me take another example. I don't know if you can see the or this platform. I'm going to talk about the diamonds, right? If you can't hear the audio, that's fine. I'm going to narrate it. The concept is how much is the diamond cost, right? I mean, probably 1 carat diamond is 4 or 5 lakhs rupees, I believe. I'm not the big fan of diamond, but I'm just guessing. So typically, uh, you know, diamonds, you're not going to buy couple of in your lifetime, right? You will buy solitaire or heavy diamonds maybe 1 or 2 times or 3 times. For I'm talking about just for average people. So when you're going to invest couple of lakhs of your rupees and where you have so much of emotions attached to it, you want to verify whether the diamond that you're buying it is authenticated, right? Uh, so this platform, which originally is Everledger platform, originally floated by IBM, I believe, which lets you the trace back the history or resume of the diamond that you're buying, right? So let's look at it quickly, and then I just probably take 2 minutes, and then we'll discuss that. Right, right. So one of the key point is the diamond smuggling is a big thing, and if you I don't know if you have seen the movie Bloody Diamond or Blood Diamond. Is one of the very interesting movie that I've seen, where they've seen the extraction of the diamond and the all kind of pain people go through. It's very eye-opening movie that I've seen years back. But so money, the diamond smuggling and stuff is a big issue, and we always wanted to know, right, that this particular diamond, Africa is one of the biggest mine, diamond mines, and like Surat, for example, which is one of the big hub in the India, or even for that matter in the world, where the diamond cleaning, diamond polishing, diamond cutting happens. Similarly, Belgium, Antwerp is one of the big diamond markets, right? So there is a huge exchange of diamonds happens in the world. So basically, in every step of a way, right, when diamond is extracted from the mine, then it went to a person who's going to clean, the company who's going to do the cutting, the person who's going to do the full polishing. Every person who has worked on your diamond is all documented in the whole chain. So there is when you buy the diamond, they give you, the company give you the certificate, right? And in some of the new technology, the certificate number is implanted inside the diamond itself, which you can't see. You need a special glass to see. But with the certificate, you can trace back the diamond that it was extracted from this company. So you know that it has been legally mined, or legally extracted, and who are the people, who are the company who has worked on it, right? So that gives a huge authenticity and traceability of the diamond. Right? So it's distributed, it's permission. Like I told you about that, the Hyperledger platform, which is blockchain 3.0, which is permissioned, right? So only the diamond company and the few people who are managing the chain, they are the one who are going to be admissible. So once you buy the diamond, you also have an entry to trace back and check the complete history. It's not for anybody to come and participate, unlike the Bitcoin, right? Bitcoin is again permissionless. Anybody can participate, right? As one of the gentlemen asked the question, can I be a miner? Yes. Versus here, this kind of enterprise solutions, they are permissioned. That means you need a prior permission to be part of this blockchain. So there is no way you can alter once the data is part of that diamond ecosystem. There is no company or no intermediary can fake anything in middle. And this, think about it, and this is the last point I will say before I stop. Think about that in a pharmaceutical company. One of the project that we recently completed for one of the client in Ireland, they wanted to build a platform which is uh, for the pharmaceutical drugs. So any medicine which leaves from the manufacturing site, then reach to all the way to the end user, which could be somebody sitting in Delhi or somebody sitting in Indonesia, right? The drug manufacturing happens, and then it goes through multiple intermediary steps. Let's say it went from, let's say, Switzerland to Zurich airport. From Zurich airport, it went to, let's say, Dubai airport. It came to India and Delhi airport. From Delhi, it came to Ahmedabad airport, and then it went to a wholesaler. From wholesaler, it went to a distributor, and then to a retail shop, right? And then the medicine has been sold. So every step of the way, every transaction is going to be recorded on a blockchain using the mechanism of QR code, right? So this company handed over the package and now give it to this wholesaler, and so on and so forth. Why it is important? Because in the world there are $200 billion fake uh, drugs, or counterfeit medicine. The business is $200 billion per year. So this blockchain technology we just talked about, right, similar to diamond supply chain, there is a huge potential that you can eliminate. So if you can if you catch any fake medicine or counterfeit medicine, then from that shopkeeper you can trace it back all the way, so that you know who were involved in the whole transaction. And those transactions are, once are entered, they are tamper proof, right? So it solves such problems in a way. Okay. So with that, let me stop here. We are almost at 12, and see if you have any questions.
Thank you so much, sir. Thank you so much for this informative session. I hope this will be useful for all the participants.
Somehow I can't hear your voice from your end. I don't know if you still.
Hello, sir.
Right.
For all the participants, there is
I
an
saw a
announcement.
note
The next
from
session will start
Subha,
sharp at
but
1 p.m.
hello. Manas, we'll fix it after the session. Yeah, yeah, sure. Thank you. Sure, okay. Hello.
Yes, sir.
Can you hear me?
Hello, sir.
Hi.
So we welcome you again, and without much ado, I'll hand the session to you. So, sir will be taking the next session on the topic blockchain platforms. And for your information, sir, the whole event is being streamed on YouTube. So
Mhm.
periodically, I will be posting the questions from the participants in this chat box.
Okay, sounds good.
Okay, sir.
Thank you. So welcome back, all of you. As we discussed in the previous session, we looked at blockchain from different industry usage perspective, right? We looked at from HR perspective, from education degree perspective. We look at from the supply chain aspects of it. We also looked at Bitcoin as application and the underlying architecture, how blockchain is enabled different applications. We have explored the demonstration of different blocks, how they connected together. So I hope we have a good framework underneath that what crypto hashing, nonce, mining, all that process works. As we also saw that mining is quite expensive, right? That and Bitcoin, the current price is, as we looked at, almost 19,000 US dollar, 14 lakhs Indian rupees, and there is a handsome rewards are still available. And as we go along and a few years down the road, the reward will get uh, reduced as we go along. So there are a lot of speculation in the world. Indian government in general are not too uh, in favor of, I would say, cryptocurrency. I mean, the guidelines are kind of keep changing, but in general, many countries in the world has still they're building their opinion and policies about it. Now, uh, the purpose of this session is to look at other aspects of uh, whole blockchain ecosystem, and there are a number of platforms which are being used in the industry. So let's start getting to it. I'm going to share my screen. Hopefully you can see it. You can see my screen, correct?
Yes, sir.
Okay, perfect. All right. So as we looked at earlier, Bitcoin, let's consider as a uh, blockchain 1.0. So today I'm going to try to cover as much as I can from the topics listed on the platform. And it should give you quite a bit of overview of what's going on, what people are using, why they are using, what are the different applications, and so on and so forth, right? So first, let's look at Ethereum, right? So Ethereum, first, before we get into Ethereum, we understand that blockchain is registry of assets and transactions, right? We also understand that blockchain is basically distributed ledger technology. Just like in accounting, in the ledger you have all, your jama udar or debit credit transactions, which get recorded on a blockchain explorer, as we looked at some of the live transactions in the previous session. Right. So essentially, blockchain, in summarize into this chart that you see on your screen, right? That you have someone requesting the transaction. Now that transaction is broadcast to peer-to-peer network, right? Which consisting of nodes. Essentially, as we discussed, that any laptop can become a node in the whole ecosystem, right? But now it's becoming the big boys game, particularly from the Bitcoin perspective. The network of nodes validate the transactions, right? The number of users validate the transactions, and based on the consensus algorithm, that validated transaction is added into your blockchain, right? So think about that. This is your blockchain now. New block is now added, and now the new block is added into existing blockchain, and then the transaction gets considered as a completed. So as we looked at in a very detail, that blockchain by design is resistant to modification of any data. Right? So that is the kind of a key block of blockchain. Now let's think about uh, blockchain 2.0 in terms of Ethereum aspects of it. So as we know that there are some challenges, right? We faced that it's first of all a bit expensive. Second, it consumes, and now this is the important point to understand, that the Bitcoin model, which works on a uh, proof of work, it has some challenge, right? That it is uh, quite computer incentive, right? So it is. I wouldn't consider that the whole Bitcoin implementation is green anymore. That means it consumes a lot of computation power and lot of resources. Because everybody wants to get the piece of a mining reward, right? So but only one party would get the reward, whoever is the first one to complete and then able to prove to others. So all the parallel computation power being used, that is kind of not you know uh, utilized in a meaningful way. That's kind of, you can say that it is getting wasted. So there is another concept being introduced, right, with the Ethereum, where the consensus mechanism are a bit different. It is works on a proof of stake kind of model, where think about this, that there is a work to be done, and there are 10 parties who claims that I can do this work, right? And the master orchestrator would decide that, okay, you know what, out of these 10 people, I'm going to choose you as a Mr. X to finish this transaction. So remaining people, let's say in the Bitcoin world, let's say 100 people, it's open to all 100 wants to be a miner, let's let them do it. So all 100 of them would be wasting the mining power or computation power or resources, which is obviously use electricity, cause carbon footprint and whatnot. But in Ethereum model, the orchestrator or master would decide that, okay, Mr. X, who are the miner, for any reason, if X is not available after he's committed, then there are backup miners, so they would be doing the mining. So they, in Ethereum world, they call it gas. That means you have to apply the gas, or you have to pay the gas to a miner in that sense. Now you might ask that how would I decide that this is the guy that I'm going to choose out of 10 who has showed the interest? So basically, whoever is going to put more stake in the ground, that means whoever is willing to, and again, I'm just giving you in a very more understandable argument, that there is a 10 people are available to conduct the mining for the Ethereum. Now, Ether is the cryptocurrency out for the Ethereum, just like Bitcoin. So let's say 10 are available. Out of 10, one of them are saying that, you know what, I am going to commit my $100. Let's say if I don't justify, if I don't finish my work satisfactory, then I'll willing to walk away from this $100. I'm going to put some guarantee that if I don't finish my work, then I'm willing to walk away from my guaranteed money, right? So that's a stake. So I have a stake in the ground. Now let's say there is another person who is willing to give, instead of 100, he's willing to give 50 as a stake. So his appetite for risk